So, this is a bit of an odd one. This is a sequel to an episode from 2 years ago, where Moritz showed you how to melt things using the flip solver. Why revisit this old setup? Well, you guys still seem to have questions about it, mostly about rendering, and also I have a bit of a gripe with the setup and other melting setups that you find online. Let me explain. Most of those setups simply end by meshing the fluid particles and then simply using this for rendering. Which is fine if you're melting 3D scans of statues, but most other objects in 3D have really fine details and clean lines and UV coordinates and multiple materials and textures, and all those things really don't work well with meshed fluids. So this is what the sequel is about, how to keep all those details as intact as possible without needing a super high-res flip sim. This will be a two-parter. In this one, we'll create a blend between our original object and our meshed fluid to retain all those geometric details, and 2 weeks from now in the next one we'll work on UVs and shading and rendering. But now let's jump into Houdini and get going. I'm starting not from scratch here, I'm starting with a pre-built scene that you can also find in the scene files download, and this is pretty much completely based on the setup that Mo built 2 years ago. Let me quickly walk you through this, what is still the same and what I tweaked. First of all, we still got the same 3 nodes in here. We got our source node. We're going to load in the object that we're going to melt. We turn this into points. We run our pyro source spread simulation to have a temperature attribute creep through our object. And then finally, we pipe this into our flip sim. Our flip sim lives in here in this AutoDop network. This was built using this melt object shelf tool right here under viscous fluids. So this is set up to use a viscous flip fluid right here. And what Mo did is he added this pop wrangle in here, which is set up to grab the temperature attribute that a pyro source spread simulation created and drive the viscosity with this attribute. And this is our main melting effect. And then finally in here, we're simply importing all the DOP data, all the data from a flip simulation, and we're running a little blast in here just to keep the points and get rid of all the volumes that flip created. So far, this is the standard setup from up, just with some parts in here removed, because this is where we're going to do the main part of our work today. Let's quickly run through the changes that I did. I first of all exchanged the main object that we're going to melt with this shader ball. I also tweaked the particle or the point separation in here for a flip simulation, and for an object this size and this detailed, this is the bare minimum of points that I'm going to simulate in here. For a production setup, I probably want to up this to a value of 0.007 or even 0.005. Also, I tweaked some values on this pyro source spread to make this look nicer for the object that I'm melting in here. This is simply an aesthetic choice. And also in this AutoDop network, on this pop wrangle in here, I modified this line here a tiny bit to allow also for a slider for the minimum viscosity of my fluid. I don't want to have this as runny as Mo did in his setup. I still want to have this a bit thicker. Again, this is purely an aesthetic choice, but I added this in here as well. This is a walkthrough done. If you need more info, you can watch Mo's old video. This is also linked down in the description. But now, let's get going and let's build our main setup in here. And first of all, I want to keep working on this pop wrangle in here, because we're using this to grab the temperature attribute from a pyro source spread simulation, but there's another attribute that I want to use in the end. Let's take a quick look at this. On this pyro source spread, we get a couple of attributes. Right now we're just grabbing the temperature, but there's also this total burn, and this total burn is quite helpful for us. If we first of all take a look at how the temperature travels through our pyro source spread simulation, we can see that it spreads through our object and is quite hot, but it later cools down, which is nice to simulate a liquid cooling down as well. But we want to have a mask attribute that stays red, and this is where our total burn comes in, because our total burn travels through our object and also stays burned like this. And this is exactly what we want as a mask. So to put this onto our flip fluids as well, let's jump into our AutoDop network, to a pop wrangle, and let's maybe enlarge our code in here. And we have these two lines here at the top that grab our temperature attribute from our pyrosim, our pyrosource spread sim, and write it onto a flip sim. And I just want to copy those two lines, paste it in here, and instead of temperature, grab an attribute called total burn. Let's write it to a variable called total burn, and let's reference that variable called total burn and write it to an attribute on our flip object called total burn as well. Something like this. Let's hit apply and accept. We're done here. Next, let's jump into a fluid object. This is already importing our flip data and blasting away all the volumes that flip also created. Let's maybe jump to say frame 11 to take a look at all the attributes that are coming in. And we've got quite a lot of them. I only want to keep a few of them, so let's drop down attribute delete. And let's on point level select everything that we want to keep, which will be my position, my velocity, my P scale, and my temperature and total burn, both of the pyro attributes that I brought in. And let's delete non-selected, and now this is a lot cleaner. Now this is also the point in the setup where I would want to cache this out. However, there's one thing that we need to keep in mind, and the one thing that we need to keep in mind is that the total number of points in our simulation right here has to stay absolutely the same throughout our entire simulation. Otherwise, some tricks that we're going to use later won't work. So first of all, what this means is we can't use the fluid compress node that Mo used in his original tutorial because this is a lossy compression. And also on our auto-dop network, on a flip solver, under particle motion and under reseeding, we have to make sure that reseeding is turned off. This is both the case, so let's now drop down a file cache node. Let's set the file path to explicit. Let's create a file path that we like. I personally like to save my caches in a folder called cache. And maybe for this, let's create a subfolder called flip. And then in here, I just create a file name based on my kip file's current name, based on the node name, and then with the current frame number, and with a bgeo.sc, because sc means that this will be compressed with a lossless compression, so it will take a little less space on disk. Now at this point I would hit save to disk, but I'm just going to load in a simulation that I already cached out. Let's bring this in, and now I have my flip sim done. Now this is also all the prep work for our fluid particles done. So let's first of all create a box around them. This is the first part of our setup done. And now I want to do some prep work on the original object. The original object with all the nice details that I want to keep later. I first of all have to object merge this in. This lives on my source geometry container, and here I created an out null called out mesh, and this should bring in a sphere right here, and the sphere matches our fluid particles. Now the sphere right here has also quite a lot of unnecessary details that I want to get rid of. First of all, those will be some geo details that I can see if I turn on wireframe ghost, which are these bubbles right here, and also these bars embedded right here to preview subsurface materials. I don't need both of them, so let's get rid of them with a blast node. And these will be the air bubbles group and the name attribute called subsurface bars. And I can select both of them with this drop-down menu right here. Then this also has a lot of attributes that we don't need, so let's drop down attribute delete. And here this will be the shot material path and the path attribute. And then finally, this is also some groups that we don't need. So let's drop down a group delete, and in here delete everything. So taking a look at our info panel now, we just have a P attribute, we just have a name attribute, which we can use to select this stand and this preview surface and this core surface. And we also have a UV attribute that we can later use for shading. The only thing missing here is a normal attribute. So let's drop down a normal node, wire this in, and let's add normals to points in this case. I want to add normals to points because this later will make some operations a bit easier, and since this is a subdivision surface object, I can easily add normals to points without changing the shading. This is our prep work done here, so let's add another box around this. And now I want to work on my melted fluid. And what I want to do both for my fluid and for my original object is I want to cut away stuff. For my fluid, I want to cut away everything that isn't melted yet. This is where I want to keep all my details. And for my main object, this object right here, I want to cut away everything that is already melted. So everything that should look nice and mushy and should really have all those flip details that I'm after here. Let's work on a flip fluid first. Right now, this is a whole lot of points, and I want to get rid of all those points that are not melted yet. So maybe let's jump to some frame in our timeline, and let's use a group expression to grab those points. Again, the attribute, the mask attribute that I want to use for this is the total burn attribute. So first of all, let's select a point group here. Let's call this solid, and let's select based on a total burn. Let's write at total burn is smaller than some slider that we're going to create and that we're going to call mask like this. Let's create our slider and let's set the value of the slider to a value of 0.035. This looks nice in my opinion. And now we're selecting just the solid half of a shader sphere right here, or shader ball. Let's blast this away. Let's drop down a blast node. Let's select solid here. We also don't need this group anymore, so let's select delete unused groups. And now I want to mesh my particles into a surface. Now I could use a particle fluid surface node for this. However, in this case, I found it a bit nicer to have a bit more control over this. And instead, I'm going to use some VDB nodes. So first of all, I'm going to drop down a VDB from particles. I have to set my voxel size a bit lower. This would usually be the same value as my particle separation. However, as I want a bit more details for the surface, I'm going to set this to 1/3 of my particle separation in my fluid sim. It's a value of 0.005. I also want to make the point radius scale half as big. This matched the surface of my original object better. And since this is really blobby right now, I want to smooth it. So let's drop down a VDB smooth STF like this. Let's set the iterations to 8. And let's use a convert VDB to turn this back into polygons. And I also want to add normals to this surface as well. So let's drop down a normal node and let's add normals to points. And I need to transfer some of the attributes from my fluid to here as well. So let's use an attribute transfer and let's add a reroute up here above a group selection by simply hitting Alt and dragging on this noodle right here. And I want to branch out from here. I can create another reroute by simply hitting and holding Alt and clicking, and then wire this down here. And the attributes that I want to bring over will be the velocity and the temperature and the total burn, like this. And let's also disable primitives. Let's take a look at our total burn because I want to use this as a mask later again. Right now this is quite jagged, so I want to blur this to make this look a bit nicer. Let's drop down attribute blur node. And in here, not select our P attribute, but our temperature and total burn. And let's blur this for 10 iterations, and this looks a lot nicer in my opinion. This is all I want to do with my flip fluid for now. This is the melted part of our object. And now I want to create the unmelted part of my object. I want to animate this using my flip sim. So what I want to do first here is have my static object right here match the animation of my flip fluid right here as closely as possible. And I can do this using a point deform node. So first of all, this should take our main object in the first input like this. Then this also needs a flip fluid. However, the second input needs a static frame to work. So for this, let's drop down a time shift node like this. Let's wire this in here. Let's go to frame 1. So this is displaying frame 1. And let's delete the channel here. So no matter what frame we're on, this node is always outputting the first frame. And then finally, we need the animated version of our flip fluid in the third input. So for this, to make this a bit neater, let's add a reroute here as well. Move this over and wire this into the third input like this. And now if we scrub through our timeline, our main object is now also following the animation of our flip fluid. I can tweak some of the parameters in here. In this case, I up the radius a tiny bit, maybe to a value of 0.3. This looks nicer in my opinion. And also, if you take a look at the surface of our object, this is a bit lumpy. This gets also maybe a bit more apparent if we drop down a subdivide node before a point deform node. This will also give us a little more detail for deforming. And this is a tiny bit lumpy and one very, very cheap and sort of hacky way to get rid of this is to simply turn off to recompute the affected normals. This may not work in all cases, but at least for this thing that I'm building right here, this looked a bit nicer than leaving this turned on. So this is the first part done. This is making our main object or detail object follow the flip simulation. What I want to do now is I want to cut away, like I did with my flip fluid here, I want to cut away something. I want to cut away everything that is already melted, because this is what our flip fluid down here should replace. So to cut away, first of all, I again need some attributes. Let's transfer those from a fluid as well. So let's drop down attribute transfer, wire this to a reroute right here, and on point level this will be again our velocity, again our temperature, and again our total burn, like this. Let's maybe also pick a different frame, maybe this frame, to work on cutting away everything right here that is red, because this is our total burn attribute. Again, right now this is quite jagged, so I want to just simply copy this attribute blur node from down here. I need this here as well. Now this is looking nicer. And now I want to cut away everything that is red. And I could do this simply using a blast node. However, I want to have a clean cut right here and not this jagged cut that a blast node would give me. And what I can do to get a clean cut line is I can use a little trick using the clip node. The clip node by default, if you just drop this down, is set up to cut away in a straight line. This is not what we want. We want to cut away along the attribute border. And again, there's a little trick that we can use here. And the trick is arranging the points before we use a clip node in a very specific way. First of all, I need a rest position, because I later want to restore the original point position again. So simply wire this in first. And now below our rest position, I want to drop down a point wrangle. And in this point wrangle, I want to move points. I want to modify the P attribute of all points. So v at P is equal to a new point attribute, a new vector that I'm going to create using the set function. And the x-coordinate of the new vector should simply be our v at P dot x, our old x-coordinate. This should also be our c value. So let's leave some room here for a y value, and let's simply paste this again for a c value and set this to v at P dot c. And what I want to use for my y value in the end is again our total burn attribute, the mask attribute that we want to use. So write this in here. As soon as we do so, we turn our object into this very strange looking height field like this. This doesn't look as useful to us right now. However, we can cut away some of this height field now with a clip node. And for this clip node, I want to adjust the distance where we're clipping. I want to leave the origin at 0, 0, 0. Let's set the distance maybe to a value of 4. And let's select the primitives below the plane that we want to keep. So now we have this tower right here. But now what we can do and what makes the magic of this little trick happen is now we can simply restore the rest position. So let's simply copy our rest node from up here. And instead of storing the rest, we want to extract the rest. And what you can now see is we cut away everything that's following our attribute border right here. And this is simply because we rearranged our points in a way that a nice and straight cut that the clip node gives us is now following the attribute and the attribute border instead of being just a straight cut in 3D space. By the way, credit for this trick again goes to Konstantin Magnus. Great guy, should check out his YouTube channel as well. But now let's keep going. And what I can do with the setup right here now is simply adjust this distance slider right here to control how much of my original object I want to cut away. And in this case, again, a value of 4 looked nice for me. This is all I want to do with the geometry, with my high-res object. So let's put a box around this as well. And now finally, I want to combine those two. So this, first of all, will be a merge. Let's wire both of those in. This is already looking quite well, but if I turn off the visualizer and especially if I turn on just smooth shading right here, we can see we have this visible border between our liquid and our main object. And this is something that I want to hide, at least a tiny bit. And what I can do to hide this is to simply blur the normals in this transition area between our main high-res object and our flip fluid. And I can only do this in a geostream where we have both our objects right here in one geostream. So to do this, let's drop down attribute blur node. We want to blur our normals. We also want to blur by proximity since both of our objects are not connected. And as you can see, we're already hiding this transition here between our main object and our flip fluid. However, it's messing with our other normals, of course, as well, and we don't want that. First of all, to get the transition quite nice, I want to set the blurring iterations to value of 3. Now this is looking even better, but the rest of our object is looking even worse. So in this case, I need a weight attribute that I want to use sort of as a mask for blurriness. Now, what I could use in here is again our total burn, and this gets us a nice result up here. But now our bottom here of a piece is looking really, really odd. And the reason it's looking so odd is because our total burn attribute is ranging from a value of 0 to a value that's something higher than 1. And this value being higher than 1 is a problem here for a blur node. So what we need to do is we need to clamp our total burn attribute between a value of 0 and 1. And this will fix our issues down here. So to do this, let's use an attribute remap node. This can be used as a simple way of clamping an attribute to 0 and 1. The attribute that we want to use as an original attribute for this is again a total burn. Now you see this is already working, but I want to keep the original range of our total burn intact. So I'm going to save this under a new name, and let's call this name blur mask like this. And now I'm just going to use this blur mask attribute as a weight attribute in here. And once we select this, now we have a nice transition between our original object and our flip fluid. And this is already also working for each frame that we select in here. And this is also the first part of the setup done. We now have a nice transition, we're keeping all those geometric details, but we also have a nice and blobby fluid. In the next part, we're going to work on how to bring the UVs and all the shaders over to a fluid to make this look nice as well. But until next time, it's cheers and goodbye. If you like what we're doing, please consider becoming a patron of ours, not only for supporting Entagma, but for access to in-depth courses on topics such as KineFX, Vellum, Vex, Python, and so on and so forth. Also, let me say thank you so much to all our existing patrons. Without you, this channel would not be possible. Thank you.